Hi, my name's Dr. Christopher Bibb. I'm a research fellow at the Extreme Robotics Laboratory, and my field of research is mainly in human factors, human-computer interaction, and human interface technologies. So really what all that means is the best way for the human to interact with the system or the robot. So a lot of this includes things like data visualization, what's the best way of displaying lots of different types of data and sensors, as well as the best methods of system interaction. So within VR this can include things like hand tracking, controllers, and eye tracking. So I'll jump right into the demo. So as you can see on the table includes what is a simulated holographic display. So this essentially means that we're using VR to simulate what a volumetric table could look like. So we can see the hands, and then you can interact with the table using hand tracking. So you can zoom in and out by stretching your hands. You can rotate the table by putting it along the edge of the table, and then drag and move the table. So if there's been a disaster, the first thing you might want to do before sending rescue people or robots into the building is have a look at what existing data sets there are. So the really most basic form of this might be floor plans. So if you bring the floor plan onto here, you can see that this has been as overlaid onto the table. You can inspect it, you can zoom in and out, and you can have a look. But 2D data like this, there's no real need to view this in VR, whereas you can bring in 3D data of survey data, for example, such as using Matterport scanners. So as you can see on here, we've got the 3D model of the Extreme Robotics Laboratory on here. You can take away the floor plan and leave just the model now. And then on here, you can, again, zoom in and out, interact with it. So using this 3D model, you can see it all stereoscopically in 3D. You can interact with the map. You can have a look where the corridors are, where all the doors are. So you can interact with the map, and then this might be quite historical data. So this data itself could be a few years old, or it could be low resolution, so you can bring in newer forms of data. So after a disaster has happened, for example, you can bring in a drone to map the area, so you can bring in updated photogrammetry data. So photogrammetry is just making 3D models from video and photos. So as we can see on here, the photogrammetry data has been overlaid onto the historical survey data. And you can see, since the disaster, lots of things have changed. There's lots of new things around the area, such as the rubble and things like that. So with this, you can use the system to try and identify things automatically, such as targets that the robot might want to look at. So you can see here, we've brought up the targets. Each one of these spinning red circles indicates what the system might think is something worthy of inspection by the robot. And then you can bring up each one of these targets and have a look at it. So for example, here's some rubble. So the automatic target recognition has suggested this as a target to look at. It has a high probability that that something is there. So on here you can see there's a 3D model. You can inspect it 360, and then you can get more information out of it. So the next thing you might want to do is try and plan the path of the robot. So on here you can see that the system has automatically planned a path for the robot to take through the area, and then this will ensure that the robot has a look at all of the different targets that have been suggested, as well as form an optimized path through the system. And this so far has mainly been used for planning. So with this, we brought in lots of historical data, some newer data, different types of data from scans and drones and floor plans, but you can also bring in live data from the robots. So on here we can bring up sensor data directly from some of the robots. So you can see up here now that there are 3 different types of data that can come from the robot. There's depth data that shows 3D information. There's infrared data, again, that can also indicate depth, and then just normal color imagery. So these 3 different types of data put together can allow the robot operator to see what the environment is, but it doesn't provide the high level overview that a supervisor might need to try and give instructions to a fleet of robots. And this can apply equally to a whole fleet of robots or land, sea and air vehicles that can be sent for inspection, and it doesn't necessarily have to be a single robot. So this supervisory control station can be used to give information to the robot operator, and the robot operator can choose to follow their path or follow their own path, either autonomously or through manual control. So this has been a short virtual reality demonstration of being able to use lots of different types of data and visualize it all in one central place. So one single operator can have a look at the whole of the disaster space, as well as being able to give instructions to all the unmanned systems that are in the area. So now I'll pass you over to the robotic control demonstrator, and that will show how you can control robots both autonomously, manually, or a mix of the both, where you can pass off command between the robot and the human. Thank you for watching.